Hello, everybody. We have been in the last lecture, we have been dealing with the zeolite process of the treatment of hard water. Zeolite process is also called as the cation exchanger process because this zeolite bed containing loosely held sodium ions, they help in replacing only the cations that are present in hard water. So that means the process is effective in removing hardness to the level of 10 ppm. But what happens is that because all anions are allowed to pass through, so the process is causes the treated water causes some other type of boiler problems like the caustic embrittlement because of the presence of sodium ions. That means the sodium ions are usually present in the form of sodium bicarbonate and sodium carbonate. Now both these salts, when they are present in the treated water, and when such treated water is allowed to pass through the high pressure boilers, that means at very high pressure and high temperature, the sodium bicarbonate and the sodium carbonate, they lead to caustic embrittlement, and which is again disadvantageous for use in boilers. This is all about the zeolite process. In today's lecture, we will be dealing with the numericals that usually come in the zeolite process. So that is there. This numericals based on the zeolite process is there in your syllabus, and we will be dealing with the numericals in this lecture. The first question is that the hardness of 1000 liter of a sample of water was removed by passing it through a zeolite softener. The zeolite softener required 30 liters of sodium chloride containing 1.5 grams per liter of sodium chloride for regeneration. So the question is, find the hardness of the water sample. So we know here that the hard water, the volume of the hard water to be treated is 1000 liters, and this hard water has been passed through a zeolite softener, and this zeolite softener, the exhausted zeolite softener required 30 liters of sodium chloride, and the concentration of sodium chloride in this 30 liters was 1.5 grams per liter of sodium chloride. So the question is how to find the hardness of the given water sample. So in this type of numericals, the first thing that we should be doing is to first quantify how much amount of sodium chloride is present in 30 liters of sodium chloride. So that will be equal to, the concentration is already given, that is 1.5 grams per liter into 30 liters is coming out to be 45 grams of sodium chloride. So that means 45 grams of sodium chloride was used for regenerating the zeolite bed. So that means we have to now convert it into calcium carbonate equivalent. So we know that calcium carbonate equivalent of sodium chloride is 45. This is 45 into the molecular weight of calcium carbonate divided by 2. So it is 100 divided by 2 whole divided by the molecular weight of sodium chloride divided by the valency, that is 1. So sodium chloride has a valency of 1 and the molecular weight of sodium chloride is 58.5. So after putting all these values in this formula, we are getting the calcium carbonate equivalent of sodium chloride as 38.46 gram equivalents. So 38.46 gram equivalents of calcium carbonate equivalent was present in this 1000 liter of water sample. So that means we know that this is the volume of hard water, and 1000 liter of water sample is containing 38.46 gram equivalent of calcium carbonate equivalent. So 1 liter of the hard water sample will contain how many gram equivalents of calcium carbonate equivalent? It is 38.46 into 1000 milligrams divided by 1000 liters. So that means 38.46 gram equivalents. You have to convert it into milligram equivalent. So that is 38.46 into 1000 milligram equivalent divided by 1000 liters. So that is coming out to be 38.46 ppm. So the hardness of the water sample is 38.46 ppm. So this is the answer to this numerical. Now let us go to a second type of numerical based on the zeolite process. The question is, an exhausted zeolite softener was regenerated by passing 150 liter of sodium chloride solution having a strength of 1.5 grams per liter of sodium chloride. So find the total volume of water that can be softened by this zeolite softener if the hardness of water is 600 ppm. So that means as compared to the previous numerical, in this numerical we have to find the volume of the water that has been softened by this zeolite softener, and the hardness of the water is already given. So in such type of numericals, we have to first calculate the quantity of sodium chloride that is present in the 150 liters of sodium chloride solution having a strength of 1.5 grams per liter. So the quantity of sodium chloride in 150 liters of sodium chloride solution is 1.5 grams per liter. So this is the concentration of sodium chloride. So it is 1.5 grams per liter into 150 liters. So that is coming out to be 225 grams. So that means 225 grams of sodium chloride was used for softening the zeolite softener. So we have to now convert it into calcium carbonate equivalent. So 225 grams of sodium chloride whose calcium carbonate equivalent will be 225 into the molecular weight of the calcium carbonate divided by 2. What is 2? 2 is the valency of the calcium ions. So it is 100 divided by 2 whole divided by the molecular weight of sodium chloride divided by the valency of the sodium ions. So it is coming out to be the value is coming out to be 192.308 gram equivalent. So 192.308 gram equivalent is you have to convert it into milligram equivalent. So you have to multiply it into 1000. So it is 192.308 into 1000 will be the milligram equivalent of milligram calcium carbonate equivalent of the sodium chloride. Now here we know that the hardness of water is already given as 600 ppm. So that means how will you represent 600 ppm? It means that the 600 milligrams of calcium carbonate equivalent is present in 1 liter of water. So this is the meaning of 600 ppm. So ppm is nothing but milligram per liter. So that means 600 milligrams of calcium carbonate equivalent is present in 1 liter of water. So 192.308 into 1000 milligrams of calcium carbonate equivalent will be present in 192.308 divided by 600. So that is coming out to be 320.5 liters. So this is the total volume of the hard water that has been softened by the zeolite softener. So this is how you're going to answer such type of numericals. Now the third numerical based on the zeolite process is, a zeolite softener was 90% exhausted by removing the hardness completely when 10,000 liter of hard water sample was passed through it. So here the catch point given is that the zeolite softener was 90% exhausted while removing the hardness completely when 10,000 liter of hard water sample was passed through it. Now the exhausted zeolite bed required 200 liters of 3% sodium chloride solution for its complete regeneration. So we have to calculate the hardness of the water solution. Now again, we have to first quantify the sodium chloride that is present in 200 liters of the sodium chloride solution, and we find that the sodium chloride present in this sodium chloride solution is 3% of sodium chloride. So that means here the concentration is given in percentage. So it is 3 divided by 100 into 200 liters. So that means it is coming out to be 6,000 grams. So it is 6000 grams of sodium chloride that is present in this solution. So that means we have to first calculate the calcium carbonate equivalent of sodium chloride, and that is equal to 6000. This is 6000 grams into the molecular weight of calcium carbonate divided by the valency of calcium. It is coming out to be 100 divided by 2 whole divided by the molecular weight of sodium chloride divided by the valency of sodium ions. So it is coming out to be 58.5 divided by 1. So this answer is coming out to be 5128 gram equivalents of calcium carbonate. So we know that the 90% of this 10,000 liters of water is equivalent to 5128 gram equivalents of calcium carbonate. So we convert it into milligram equivalent of calcium carbonate. So that means we have to multiply it 5128 into 1000. So it is 5128 into 1000 milligram equivalent of calcium carbonate, and this is equivalent to 90% of 10,000 liters. So 1 liter of water will be equal to 5128 divided by 1000 divided by 90 divided by 100 into the 10,000. So that is coming out to be 569.8 milligrams per liter, or it is nothing but 569.8 ppm. So the hardness of the water solution is 569.8 ppm. So these are the three examples of numericals based on the zeolite process, and these numericals are very important aspect of this chapter. So hope you have understood this. I will be giving more amount of exercises on this zeolite process, the numericals based on zeolite process, which will help you to understand the concept more easily. Thank you for listening to me.